Water. You can't live without it. It's one of the most abundant molecules on the planet and in our bodies, in the bodies of all living organisms. It can be serene and peaceful and life-giving, but it can also be destructive. So we need to understand how water works for us and against us. And so it's important to understand water from a variety of perspectives. One, let's just talk about big picture. If we have a container of water, not all movement of water is by osmosis. As we study that later, it's kind of tempting to think about that, but water can flow just like this water does, right? If we give some energy to it, it's going to go from areas of high energy to low, where it's a little more stable, whether that's downhill or from high pressure to low pressure. Important in our body, especially in terms of moving blood around. The other thing that water will do is it can go from a liquid to a gas, and if we heat it up, then that water molecule turns to vapor, and then it can also condense on the side if this is cool water, and you've had this happen where you get a little puddle around the glass. It goes from vapor to a liquid again. And so those are a couple of different ideas that we can change the state of water from a gas, the water vapor, to a liquid, and then finally to a solid. And we really want to avoid this state. These two are pretty natural. When we sweat, water vapor is given off and it cools us down. Most of our water is liquid, but if it becomes solid, that's a real problem. And the odd thing there about water that's unique among almost all the molecules on Earth is that the solid expands compared to the liquid. You know that if I were to put this water bottle in the freezer, then I need to have some airspace in here to allow room for expansion. If I filled it all the way to the top and put it in the freezer, this thing would break. So that's kind of a unique property and something we'll circle back to in a moment. Another important type of water movement is osmosis. We'll talk about that plenty later in the class, but it doesn't really apply to all water movement. Really, it's only water, if this is a cell, water moving across that membrane, usually following salt, is osmosis. But not all water movement is osmosis. All right, so on from big picture to a couple other details. Coming back to this one in particular, if a solid expands, or the solid state of water expands, then that means our cells would also expand, and this phospholipid bilayer around them would just crack. And so ice kills cells. That's why we go through so many efforts to stay warm and keep that from happening. As a gas, when water moves from a liquid to a gas state, it takes a lot of energy with it, and so that actually cools us down. So some of the properties that are important about water is that it tends to stay liquid, so it doesn't change state real easily. And part of that reason is that its temperature tends to remain fairly stable because it has a high specific heat, which means that, and you've experienced this too, water is difficult to heat up or to cool down. When you put water on the stove, it takes a while for that pot of water to boil. You probably haven't tried to boil a lot of other liquids. Hopefully you haven't tried to evaporate gasoline. You know that alcohol, if you put a little bit of rubbing alcohol on your skin, it cools off really quick because it evaporates so quickly. But water, it cools your skin down, but it does it a little more slowly. And so it tends to resist changes in temperature, and it keeps us fairly stable if our body is mostly water. When we start running out of water, there's a little less temperature stability. And there's some other really sophisticated ways we can study this temperature stability, but I'm going to leave it at that for now. Another one, and I'll use the loose term, is that water is kind of sticky. It comes back to those polar bonds, polar covalent bonds. When we draw out a couple of water molecules, then we know that there is, because of the difference in electron distribution between these, there's that attraction between this negatively charged oxygen and the partially positively charged hydrogen. That means water sticks together. I mean, you've got to figure in a water bottle like this, there are trillions of water molecules in there, and all of them want to tend to stick together. It also means that if you put water next to a different object, and this is composed of other polar molecules, the water wants to stick to it. It's not difficult to demonstrate, right? If we take a little bit of water, put it on here, we find that it sticks to that paper pretty readily, and even will start to spread out. You know that. It forms this little pool right here like it is right now, right? But then it's going to start kind of wicking out in a way and changing. It's bleeding into the paper below. But water likes to stick to other things, and that's important to help water move up plant stems, to stick to different compounds inside of our cells and whatnot. So those are some of the key properties of water. There are many more. They're important to living things, but that's a good overview of a vitally important molecule in all of our lives, water.